Nice. So, hello everyone. Before I start, I also wanted to give a big round of applause to this amazing organization. It's not easy to organize an event, especially one that's really good like this one. So let's wake up a bit more and just give a big round of applause to everyone. And of course, it feels really good to be back at the in-person event and to meet all of you. So also a big round of applause to you. Welcome to this adventure of Kotlin and Compose through the multi-platform world. Just for me to have a better idea on the beginning, so who has already played with Kotlin multi-platform can just... Nice! I'm really surprised. Really like these numbers. And who has an application in production with Kotlin multi-platform? Okay, it's smaller, but we're going to get there. So let me start by saying, I'm Carlos Mota. You can find me on Twitter at @Mota. I'm an Android GD, founder of GDG Coimbra. I've been writing at Ray Wanderleek. I love to travel, photography, and running, and I look forward to taste a Moretti with all of you. If you're not a fan of Moretti, and then know this is a sensitive subject, I'm also open to try another beer. So feel free to select the best one that I'm going to drink it with you. I've created a couple of materials for this talk. I'm going to tweet them all out at the end. So you can find my slides at Speaker Deck. I've created an application with multi-platform that you can also find at my GitHub. I've written a book about Kotlin multi-platform. And I can have here my small YouTube moment saying that I'm trying to create a channel, so feel free to subscribe. So I thought it makes sense when preparing this talk to say, okay, how should we start to develop an app? Okay, and what I'm going to show you here, it's my point of view. So I guess, spoilers, I'm going to choose Kotlin multi-platform for this. But in the end, this depends a lot on the requirements, on the project, on your team. So let's go a bit through all the steps of developing an app. So imagine that you're going to develop an app. There are usually three things that make you develop an app. So you have a great app idea. You want to solve an issue. You're going to be paid for it. So this is true. Or there is a shiny new framework that you want to test. So you decided to create a pet project just to test that framework. So the first thing important is requirements. What are you going to develop? Are you just going to create a proof of concept, something that it's only for testing purposes? Are you just going to build an MVP and you want it to make it quick? Or are you going to develop for just a single platform, more platforms? And of course, it's just going to be something really simple for 1 year? Or are you going to develop it for the next 10 years? All of these things matter when selecting the framework or the SDK that you're going to use for your project. Along with these requirements, it's also important to know your team, or if you're going to be the only developer of that application. So are you going to have a team? Or are you going to be basically the jack of all trades that's going to be continuously switching from Android to iOS to the web and so on? So all of these things matter because if you're the single developer, perhaps you want to just have a single code base. Also, can you increase your team and have a specific person just for Android, another for iOS, another for the web? All of these things are important, especially if you want to create great applications. Along with this, and a bit further the line, there is the project itself. So sometimes when you start a project, there are a couple of constraints. Sometimes you start a project and it's already delayed, and you need just to speed up the development. Sometimes there's no time to learn new things. Sometimes you can hire a couple of people or grab a couple of people to your project, but unfortunately, most of the times, this is also not possible. So we need to juggle a bit with all of these questions. Also, in the end, it's important to know that if you're going to develop for just one platform, or if you want to target all of them. This brings us to the next question. When we want to target to multi-platforms, and once again, this is my point of view, I know that there are a lot of articles about this, There are also a lot of rewrites. For instance, Airbnb started with React Native and Notion because it made sense at that time. And further down the line, it made sense to rewrite their app. There's no problem with this. It was something that they wanted to build and ship things fast. They used React Native. Now they want to have performance and stability and moved to native. So sometimes there are a couple of cross-platform solutions that arise. And of course, and this is something that I tried to do on the other day. So I was basically using Instagram and I wanted to share to Facebook. And I'm just going to play this video once again and pay special attention to the spinner. So this one. That spinner existed when I started working with Android. And this was like 10 years ago. And we're talking about Facebook or Instagram. So we're saying that for 10 years, no one remembered that they should have updated that component. And this happens a lot when you're using these cross-platform solutions. And Facebook is used by millions. This is also another thing that was a bit trending on Twitter a couple of months ago, because this was Flutter, and someone created a library, but the person that created that library created for Android. So this is running on an iPhone, and it seems that you're running an Android code on an iPhone. And let's be honest, well, who has an iPhone over here? Just, okay, I'm going to be cautious. So typically, Android are more used to have things that are not as consistent or as shiny, but iPhone are really picky when they see something that it's an anti-UI pattern like this one. And the thing at the time was a lot of iOS developers were complaining that they wanted to use Flutter, but the components didn't follow the UI guidelines. And I have a great story about this. I once had an application built with one of these tools years ago, and there was a new iOS release, and that iOS release changed the old UI, so that it was completely different. And when the new release is launched, typically iOS users update it on upcoming 2 days. It's like something 85% of users updated. So they updated. I didn't have that many users, but they updated, and they were still seeing the old UI of my app. Because using a cross-platform solutions, most of the times there are widgets, and the application needs to be rebuilt and sent to the store. At the time, I waited 5 months for that specific framework that I'm not going to say the name, to launch their update. After this update, I needed to recompile the app. After recompiling the app, submit it to the store, wait for Apple to approve, and users to install it. I lost 60% of my users during that time period. Once again, it was a small application. I wasn't mad about it, but it really made me think about these cross-platform solutions. And even then, there were people that didn't update the new iOS, and they saw the new app with the old design. So it doesn't give you the best experience. So when selecting one of these frameworks, and this first point is also valid for this talk, be extremely careful about the demo effect. Everything sounds nice, and it's amazing on demos, like this one. But be careful and test and see a lot of comments on Stack Overflows on the internet about the issues that people have. Also, sometimes when there is a feature that's only available from one of the platforms and not the other, typically it's not implemented on the framework, and you need to rely on third-party plugins, or you need to develop your plugins. You're going to be dependent on the framework. I know that this is also subjective and a cautious phrase, but the performance, it's not going to be the same. Okay, so you've got a layer in between. It's not possible to have the same performance. And I show you an example from Flutter. There was also a thread, and it seems there is a Flutter issue reported for quite some time, that if you try to scroll with 2 fingers on a Flutter app, the animation is not as smooth as it should be. Of course, we're talking here about corner cases, and I don't know, I don't scroll applications with 2 fingers. But, well, these type of things exist. Once again, I'm talking about Flutter, but I know that Flutter makes sense on a lot of scenarios. I'm not going to say that Kotlin Multiplatform is better or worse. It depends on your project. Of course, from my point of view and of my experience, I'm here to advocate multi-platform. And you're committing to a single framework. So what's going to happen in 5 years' time if the framework stops to exist? Are you going to rewrite your entire project? Are you going to write a framework in your project? Well, there are a lot of things that you need to take into account before selecting one of these tools. So I've got an answer for you. I guess you are all figuring out what it is. It's called Kotlin, and namely Kotlin Multiplatform. So I know that a lot of you are already familiar with the subject, but I just wanted to give some guidelines about what Kotlin Multiplatform is. And the first one is that I've read a couple of times that there are people calling it a framework. It's not. It's an SDK. So it's really easy. You're not dependent of the framework. You just have an SDK. It's developed in Kotlin, and we know all love Kotlin, right? Just give a round of applause to Kotlin. I hope someone tags JetBrains about all of this advocating. I'm kidding. So Kotlin Multiplatform was built with a single purpose. It's not to share everything. It's just going to share your business logic. This was the beginning, and you're going to see that now there's more to it, but the initial beginning was to share the business logic. And the best thing is that you can decide what you want to share. So different applications share different things. And I've been talking with a couple of you, and I noticed that the ones that were using multi-platform, that some of you were sharing just the data objects, some of you, okay, some of you want to share everything. Some of you were sharing their repositories. I've been sharing different things on my app, so it depends a bit on what makes sense, and of course, if I'm developing multi-platform or not. And the great thing also about multi-platform is that imagine that you start to follow multi-platform, and for some weird reason, it doesn't work on your project. You don't need to rewrite everything. You can still use this code on Android, and you just need to write the iOS code. So part of your project is already built. There is nothing that's going to be wasted. And the UI should be developed natively. Of course, you can also use a framework for this. You don't need to do it natively. There are a couple of projects that are using Flutter with it. Or you can share it. Spoilers. So another, just going to give a bit overview about a couple of keywords that you're going to listen. So a couple of years ago, you were going to listen to MPP, that's called multi-platform. It was rebranded to KMP, Kotlin Multiplatform. And Kotlin Multiplatform means WebAssembly, GS, JVM, Native, and KMM. KMM stands for Kotlin Multiplatform Mobile. When we talk about native, we talk about the desktops, and we also include on here iOS. When we talk about Kotlin Multiplatform Mobile, we talk about Android, and we talk about iOS. iOS, watchOS, and tvOS. Kotlin Multiplatform Mobile is going to see the beta version until the end of this year. At least it's what's on the roadmap. And it's something that JetBrains has been investing heavy in. So Kotlin Multiplatform Mobile has been basically they subset Kotlin Multiplatform just to focus on mobile so we can start from a specific place. So when we talk about Kotlin Multiplatform, how can we start? You just need to install the Kotlin Multiplatform Mobile plugin, and you can create a simple project from Android Studio. Of course, you also need to have Xcode installed if you want to run it for iOS, but you can run it for the simulator directly from Android Studio, which is great. There is also a simple project called the Camp Kit. This was done by TouchLab. It's updated to the latest libraries, and a lot of people are starting developing Kotlin Multiplatform from it. So also when you talk about multi-platform, there's always that question that, different platforms have different things. For instance, if you want to print a log, on Android you use the logger function. On iOS you can use nslog. On the console you use the console. So how can I create a library for this? And the answer is you can use expect. So if you see here, I've brought a clicker that's I bought the clicker. So you're going to have a keyword called expect. This expect means that you expect someone to define, in this case, what name really is. And you want this name to be the platform name. So you want to show Android on Android, iOS on iOS, and web on web, for instance. You can also see here that all the platforms, all the code, all the business logic is inside this common main folder. And all the expect code should be on this same folder. So I expect someone that's going to define name. In this case, I'm going to target Android, desktop, and the web. So on all of these platforms, I'm going to use the keyword actual to say what name is. In this case, I'm going to say what actual means for Android. So if this application is running on Android, it's going to say Android. And then I'm going to do the exact same thing for all the other platforms. When you compile your code, when you create an IR package, or when you create a framework, none of the other platforms' code will be there. It's also important to see that if I'm running on Android, it's going to use this package, the desktop this one, and web this one. Of course, if you're also targeting iOS, you're going to see iOS main. So the goal of multi-platform is to have the business logic. So imagine that you're going to create an application, and you're going to do it for Android. You're going to use, for instance, Room for the database, and you're going to use Core Data for iOS. For the web, you're going to use Retrofit. For the web on iOS, Alamo Fire, and so on. So there are a lot of libraries that do the same thing on different platforms. And the goal of multi-platform is just to use a single library. So you have just a code base for your business logic, and you're going to use these libraries for this. You don't need to rewrite the same thing over and over and over and over again. Also, when different people write different things on different platforms, they usually write things differently. So sometimes someone decides to implement a cache mechanism and you don't have it on other platforms, so your users are going to have a different experience. This way, you guarantee that you have the same experience on all platforms. And then the UI can be developed natively. So this is a list of a couple of libraries out there. They are really, really good. The community is heavily betting on Kotlin multi-platform, so you're going to see a lot of libraries that were built by the community and maintained by the community, which is great. And there is also this link, this KMM Awesome, that contains a lot of more libraries, a lot more resources. Basically, you can see it as a single repository. When someone develops a library, it just makes a PR for this repo. So if you're going to start with Kotlin multi-platform, my suggestion is use the new native Kotlin memory model. If you're going to use the new version that was released this week, 1.7.20, this is already enabled by default. If not, you just need to define it on Gradle properties. For iOS developers, you export your libraries for iOS. The way that I convinced my iOS team that we should switch for multi-platform was that they were only familiar with the UI kit and they wanted to learn Swift UI. So basically, what I did, I went to my cave and I planned this plot, was saying, okay, you can learn Swift UI, but we're going to do the business logic so you are not delayed on the features. And they were really happy with it without knowing what I was going to do. And at the end, they left because they could start to learn Swift UI. And when they needed to implement the functionalities, they did only to connect to the business logic that was already built. It was already tested by the Android team. So they got that for free. And they loved it in the beginning until they realized that, well, more than half part of our application now it's multi-platform. Now sometimes they're a bit behind if we should do things that way or not. But in a sense, they're really happy with the results. And I'm just saying this because, well, we always tried to say that we want all our code to be Kotlin, all our code to be Swift. But things work really, really well. And I would say that the worst thing is the compilation build times. That has been improved. And now with the 1.7.20, the size reduced in 20-30%. But you can use the CI for this, and you can just fetch the library, and yeah, it compiles there, and you always have the latest one. Hello. Everyone that's home, hello. So a couple of key takeaways. So once again, it's Kotlin. It's a language that we all love, that have a lot of features. It's low risk. You decide what's worth sharing, and if something goes terribly wrong, you also have already done it for Android. It fastens your development. You're going to develop it only once. It gives you consistency across all platforms. Also means that if you're going to have a bug, you're going to have a bug on all platforms. But if you see the cap as half full, if you fix a bug, you're going to fix a bug on all platforms. So that's great. And there's a really strong community support. The Kotlin Lang Slack, it's something really, really good. And everyone there has the same feeling that they want Kotlin multi-platform to succeed. And they're always there to help you. even not the community, but even JetBrains is there to help you. So a couple of applications already using multi-platform. Cash App, VMware, Netflix, for instance, announced 2 years ago that the Studio app was going to multi-platform, and they were really happy with the results. Different applications share different things. Once again, if you're going to listen to their talks, they say that, okay, we share the offline management, we share the network. So they share what makes sense for them. And now that we've talked about multi-platform, the next step is to talk about Compose. So who here has already played or is working with Compose? Just, okay, nice. It's not that different than multi-platform. So you all hear these keywords. So Compose allows you to write less code. It's intuitive. It makes your development faster. It's really, really powerful. And this is all true, to be honest. I've been really, really happy with Compose. Once again, there are a lot of applications in production already using Compose. Twitter, for instance, announced a couple of months back that they've switched to Compose and they only want Compose nowadays. So after talking about Compose, it's important to mention that it's more to Jetpack Compose than initially it meets the eye. So Jetpack Compose, it has all of these libraries. So it has the compiler, runtime, UI, Material 3, Material, Foundation, and Animation. And you can group this animation, foundation, material 3, and UI into what we can call Android UI Toolkit. So this set of libraries are the UI Toolkit of Android, and Material 3 was launched a couple of months ago. And then we have the Compose compiler and the runtime. If we start by the compiler, so it's written in Kotlin. If you have trouble sleeping, you can look at the source code on this link. You're going to have more trouble sleeping. It doesn't use the annotation processor. It transforms the composable annotations that you have into UI, and it doesn't impact the build times and gives you freedom from XML. You have also the runtime. You can see it as a tree management solution. It doesn't know what UI is. It's completely platform agnostic. And then you have this Compose UI Toolkit that Google and JetBrains created that's composed by Composed. Animation that allows you to make animations, the Material 3 and the Material Design components, the foundation that contains the basic building blocks of your apps, and of course the Compose UI that allows you to draw and have layouts and text input on your applications. So a great thing about this, and this is what I'm going to talk next, is that we can have the Compose compiler runtime, and then we can create a UI toolkit for each one of the platforms. So we can have it for Android, desktop, web, console, and to all the iOS developers out there, to iOS. So a couple of suggestions when you talk about Compose. The company's libraries are really, really good. And you need to be a bit careful about the Kotlin version that you're using and the Compose version that you're using. I know that Kotlin was released last week, and Compose launched a new version 2 days ago or 3 days ago with the latest Kotlin version. But yeah, you cannot update it immediately. You should wait 1 week just for have the version that also has the latest version of Kotlin. Once again, it's Kotlin. We all love Kotlin. I'm going to say this a lot of times. Once again, it also has small risk because you can still have XML in your code. You don't need to have only Compose code. You're going to develop a new feature. You can start that new feature with Compose and see if it works for you. Once again, faster development, you can reuse code a lot more easily, and it's simple to implement a design system. We've struggled this for quite a while, and now with Compose, we're happy to say that we finally have a proper design system, and creating themes, updating components, it's really, really easy. So we want for multi-platform development, Kotlin and Compose. So how to develop a multi-platform app? And I'm going to show you the example that I've created. This is the Android application. Just a simple application. We have a navigation bar. We can switch screens. We can search for something. In this case, from Portugal. I'm from Portugal. I'm fetching the images from Unsplash API. So I've got network requests here, parsing data, and so on. And then I decided, OK, I'm going to share this code and create an Android Wear app. So the same code can also run on the watch. And I went a bit further, and also created a desktop app. Once again, I'm using the same code that I'm using on Android app. I'm sharing it to the desktop. And you can see that it's a desktop because I'm going to increase the window somewhere. See, it's a desktop app. And then a bit of drum rolls. It's also working on iOS. The exact same code is shared across all the platforms. So this is running on iOS Simulator, the exact same app that I've built for Android, and then I decided to share it with desktop, Wear, and iOS. So once again, be careful with the demo effect. Okay, I'm going through it in a couple of slides. And it's also possible to have it for the web. This is Compose for the web, although in this case it's not shared because the Compose, it's a bit different here. The functions are a bit different, and trying to share everything for the web, it's really complex, let's say. So how can we do this? We've shared all the business logic, so the business logic is shared across all the platforms. There are no issues here. For the UI, it's developed in Compose and shared with Android desktop and iOS. So it's the exact same code running on each one of these platforms. Also, web uses Compose, although once again, it's a bit different, as you're going to see. So how to share everything? There are a couple of constraints. The biggest one is that, well, we're Android developers, so we are already familiar with the R class. The R class represents all the resources that we have on our Android phones, on our apps. But this doesn't exist on the desktop or on iOS. There is no R class that we can use. So we need to find a way to access the same things differently. Also, there are a lot of things that are Android specific. For instance, the navigation, the life cycle, the view models, the live data, the flows, all of this is Android specific, and it doesn't exist on the desktop or for iOS. So there are a lot of challenges. And once again, we've got Kotlin Multiplatform to the rescue. This is why it's called Compose Multiplatform. So when something doesn't exist, you can always create your platform-specific implementation. You can use libraries that already give you this support. There are a couple of libraries that are already ready for the desktop, for instance. And for those that doesn't have that support, you can always create your own. So you can add this multi-platform to existing libraries. Sometimes it can be something as easy as just adding the JVM target if you want to build it for a desktop. A lot of times it's more complex than this because there are things that are just Android specific, and you need to implement the same things for desktop and iOS. A bit further down the line, there are a couple of libraries that I'm using, and I'm really happy with them. This one is a version of a company's libraries. It was created by the user CR10 that already support Compose for Android, desktop, and native, so for iOS. And you just need to import this version. This user is keeping updating this version, so basically it's almost at the same time as the companies made by Google, but this one allows support for everything. There's also an issue on the companies from Google library, but it's still a work in progress. I was using before, when I had only Android and desktop, the Camel library. This library is pretty good and already gives support for fetching and loading image locally for Android desktop, but the iOS support is currently under development. I've been testing it, and it's not yet there, but fortunately, TouchLab created it's not really they created a library, but they give all of this support. So I basically grabbed those classes and added the desktop support and call it TouchLab image, which is on this project. And basically what they did was they're going to use Coil for Android, Coil Compose, and then they're going to use a library made by the user KDSFDHVH. That's called the Compose Image Loader, and depending if you're running on one platform or the other, you're going to use one library or the other. So I grabbed all of these files, made a few changes for the project, and called it TouchLab image. I'm also going to use Mocha resources. Mocha resources is a really, really cool library. Basically, it allows you to share resources across all platforms. So imagine you have the strings file that it's only Android specific. What Mocha resource does is you can have this strings files in your common model, and when you compile your app, these strings start to be available for Android, iOS, and desktop. They do this on compilation time. And I'm also using pre-compose because they already give support for navigation, for view model, for all of these things that are Android related. And basically, I just needed to switch package to this version, and everything worked outside of the box. So imagine that you want to share your app screens. So let's see how we can do this. We want to run it on Android, desktop, and iOS. And let's start by a simple example. OK, imagine I have hello world. Hello? Hello, everyone at home? So if we want to do this on Android, for instance, we do something like this. We've got a column. We're going to say that it's going to fill the entire screen. And we want its components to be centered on the screen. And I want to display a text. Okay? If I want to do the same thing for the desktop, it's the exact same code. And if I want to do the same thing for iOS, once again, it's the exact same code. So basically, well, we can just have this on a file. And we can implement this library, right? So the best thing here is to create a shared UI library, for instance, add those files over there, and then you can just need to move those files over there, so delete it where you have it, and then just import this library and call these functions. And you don't need to do anything else. Okay, so import these libraries, and you've got this for free. Now comes the difficult part when you want to use the resources. So once again, imagine that you want to display text, but this time you want to internationalize this text. So if you want to do this on Android, you're going to do something like this. You're going to call string resource and access star class string hello world. And if you want to do this on the desktop app, for instance, well, you don't have the rstring class. So we're going to have, for instance, just an hard-coded string. And we want to give support also for the desktop, and of course also for iOS. So how can we do this? Once again, the Mocha resources, it's a library for this. What you need to do for achieving this is you've got your shared UI library. Okay? On this shared UI library, you just need to add the Mocha resources to the class path, to the build.gradle, and then to import this library, or to call the implementation for this library. Sorry. Now you typically have the strings file under the res folder for Android. In this case, you need to have your strings file on the folder common main resources /mr Mocha resources, and then base. If you also want to have Spanish, Italian, Portuguese internationalization strings, you just need to call and create a folder called en, it, pt, etc. And then you need, once again, to go a bit to multiplatform and just create an expect function. So you're going to create a get string function, and we're going to load this a bit different. So on Android, you can just call string resource to string with app context, and you're going to get that string. If you want to call it from the desktop or for the iOS, you just need to call the localized from string resource. And now, if you want to use this on your project, you just need to call get strings. And this code can now be shared and run on all these platforms. Now, if you go a bit further down the line, it's important to mention that sometimes you might see this error, okay, on iOS if you use Compose iOS. Basically, what happens is, well, iOS is still experimental, and you might need to, there is a function over there that's called copy resources, and when you create the IPA file, you need to select copy resources so that the resources are copied from the common main to your project. After saying how to share strings, also all applications have images, so how can you load an image? So let's see a quick example, and when we talk about images, we have three different types of images that we can have. So we can have local vector graphics, okay? These are on your APK files, or on your IPA files, or on your apps, and they are supported already on all platforms, and basically, this can correspond to an icon. So if you use one of the material icons, this is already on the material library, and you can just import it, and it will work on all the platforms. If, for instance, you have an icon that it's not on that library, there are tools that you can just call SVG to compose and have that icon available for that library. So the code is basically this. It's going to convert to composable code. And if you want to import it and to show it, for instance, this search or for this class, you just need to call the icon, and instead of sending image, for instance, you're going to say image vector, and it will automatically work on all platforms. So this is the easy part, okay? Vectors are already available for free. Now, you can also have local images. For instance, your app icon. This app icon is already built in on your APK file or on your IPA, and imagine that you want to load it and show it on the screen. So this is a bit tricky, and there are two ways to do this. If you're only using Android and iOS and the desktop, you can just have the Android the files on the Android main, and you can have the desktop files on desktop main. And then you can just create an expect actual function for this. So you can create an expect, for instance, I see about, and then you just need to say how are you going to load those files. So I'm just going to have a painter and access it from the R class from Android, and if I'm running on desktop, I'm going just to send the path, and I'm able to access that file. Now, the tricky part happens if you have a lot of files over here. So we need to do this for all your app files. This can suddenly become a bit tricky, and let's be honest, it's quite tedious to do this for all your local images. And there's also another problem, which is, okay, how can we have this on iOS? Because iOS, it's the difficult part here, and once again, it's still experimental. So the solution for this is this TouchLab image library and to use Mota resources. So basically, we're going to use the TouchLab image to load image for Android, desktop, and iOS. And basically, we're going to access these images that are on our common main via Mota resources. So Mota resources allow us to give a path, and we're going to send that path to the TouchLab image library, and it's going to download or to load the images. So if you want to have local images on Android, on the back end, it's going to use the context resource get identifier. The desktop translates this path and just uses as a path to load an image. For iOS, you need to decode it. You're going to use UIKit, and you're going to use schimage to load that content, that byte content. And instead of having an image, you're going to have a bitmap painter that you can use. So in the end, if you want to load a local image, you just need to call local image, and you have it for free. Now imagine that you have remote images, like the ones that I had on this example. They need to be fetched, they need to be stored, they need to be cached, and they need to be decoded so they can present it. Once again, basically what we're going to do is use the TouchLab image, that underneath what it's going to use is libraries that were already made this possible. So when you call the remote image function with a URL, what it's going to do is, if you're running on Android, it's going to use the Kotlin Compose library. If you're going to run it on desktop or the iOS, it's going to use the Compose image loader. And with this, I'm able to share all the code between all the platforms. I know that this is a bit heavy to take on, so I'm going to be here for the entire days of the conference. If you have questions, feel free to reach me. But you can now load an image just calling remote image. We can go even further and just have an image class and detect if it's a local or it's a remote one. But for the purpose of this demo, I just created two functions. So I've talked about the web. Where are we? So the web paradigm is a bit different. It's more focused on the DOM rendering, and you can see that not all the components are available at this moment. It's also not their focus, but you can see it's a bit different. So this is Compose code, basically, for the web. So you still need to use divs, flags, grows, margin buttons, all of these web-related things. And you can also use the composable image. Of course, you can just grab all of these and create your own composable function that you then can use. But do this on a multi-platform level starts to be too heavy and too complex to do this for all the possible scenarios. So this is why I don't share the code with the web at this moment. When you also talk about the web, the sharing logic works 100%. It's important to mention that the final GS file, it's going to be a couple of megabytes. So you need to shrink it, try to zip it, just to reduce its size. And sharing the UI, once again, it's not entirely possible. It's too complex on the beginning. In any way, it's important for you to know how to do these things and what we can expect for next year. iOS, and I know that all the iOS out here are quite curious for my findings here. So it's also possible to have it on iOS. Once again, the shared logic works almost perfectly. Please enable the new Kotlin native memory model. Sharing UI, it's experimental. So it's on its early stages, and you might find crashes if you tried to add a lot of things to your app. But the Droidcon Kotlin app is on the store. Apple approved it, so it's a good thing that Apple is approving apps that were built with Compose. So the future is bright, for us at least. Once again, look out for the demo effect. I know that it seemed shiny, but I had a couple of headaches on the beginning just to have everything together. So once again, it's working for this demo and another one that I did, but yeah, I spent a couple of nights trying to understand some pains, let's say, especially the one that I linked with the copy resource not working. Not all libraries support this. Font customization, for instance, it's only possible if you use Mocha resources. So a lot of things are only possible if you use Mocha resources, but the cool thing, it works. And debugging it can really be really complex. So looking at the stack trace from the iOS, it's not the easiest thing to see. The Watch OS, it's coming soon, okay? At least it's what we all hope. There was already a PR done that it gives us a hint that perhaps on the upcoming months, let's say, we're going to have something. For now, it's not possible to share it because there is no deploy for the watch. Some key takeaways, why this is important. For instance, at my company, all the management uses an iOS device, and not only the Android team and the QA team have Android devices. And sometimes it's important to use the desktop. So now they can use the Android version on the desktop, basically. And they also manage to sell it to clients. So they also earn money with this. And you can do the same. And this is almost gave a bit for free. Also, iOS and web are giving its first step. So once again, the future is bright. Let's see what we've got on our way. This is just a small brief of everything, some key takeaways. Kotlin Multiplatform Mobile is stable-ish, so on my point, it's stable. Although the beta version is going to be launched this year. But from what I've been finding and talking with people, it's stable to be on production. Compose Android is stable. Desktop is stable-ish. So sometimes when you resize, there are some missing frames, but for the purpose of using on desktop and a platform that you get for free, it works really well. Web is alpha, iOS experimental. Documentation and samples are getting better. I'm counting with all of you that are playing with Kotlin Multiplatform to improve this documentation, and the community and this support, it's just amazing. So once again, the beta release is going to be launched. The Compose Multiplatform should be launched, the final version. It's currently on beta 02, but it should be final at the end of this month. The Jetpack release was released yesterday, 2 days ago, so in the upcoming weeks, we're going to have the final for Compose GB. On Droidcon Italy, we're going to have awesome talks about Kotlin Multiplatform. So KMM Survival Guide today, and we're going to have the roundtable about Kotlin Multiplatform also today. Tomorrow, we're going to have the Adopting Kotlin Multiplatform in Brownfield Applications. And we're also going to have awesome talks about Compose, and I'm already saying that they are awesome, so no pressure. Recompose your UI, develop your OS apps, making apps adaptive with Material and Compose. And I'm just going through these final slides. I've gathered a couple of resources so you can follow more about Kotlin. Once again, these slides are going to be available. You can just go through these links if you want to know more. Of course, you can also ping me on Twitter or talk with me at the conference. So I don't know if we have time for 1-2 questions.
Thank you, Carlos. Yes.